And welcome back. And we're going to add to our toolkit of discrete probability distributions that we want to be familiar with. Okay? These discrete distributions are covering common experimental scenarios. So far, we should have seen the binomial distribution. We should have seen the hypergeometric distribution being very closely related, one involving sampling with replacement, the other involving sampling without replacement. So what we're going to do here is we're going to consider an experiment with the same properties as a binomial experiment. Same properties as a binomial experiment. Same properties as a binomial experiment. So what are those? What are a couple of the key properties we need for a binomial experiment? Is that the repeated trials are independent. We have repeated trials, and they are all independent. Two, each trial yields a success. Each trial yields a success with probability p, constant probability p. Success or failure. It's either success or failure. Failure with probability 1 minus p. We tend to write that as q. 1 minus p. So in a binomial experiment, the number of trials is fixed, and we let x be a random variable that's going to count the number of successes in those trials. In a negative binomial experiment, though, in a negative binomial experiment, what is different here? In a negative binomial experiment, we don't fix the number of trials, but we fix the number of successes we want to get. And we count the number of trials it takes to get that number of successes. So very closely related to binomial. In a binomial, you're fixing the number of trials, counting the number of successes. In negative binomial, you're fixing the number of successes, counting the number of trials it takes to get those successes. So let's write that down. The trials are repeated until, let's say, k successes occur. K successes occur. So x, a random variable, is the total number of trials needed. X is counting the total. Let's try that again. Total number of trials needed. Negative binomial experiment. In this case, let's take a look at the PDF that x is going to have. X has probability mass function. In this case, it is B star is the notation. X counts the number of trials to get k successes with a fixed success probability of p. Probability that x is equal to x. And this is equal to, this is going to look similar to the binomial distribution, but it's slightly different. It's x minus 1, choose k minus 1, times p to the k, times q to the x minus k. And this is good for x equaling k, k plus 1, k plus 2, yada, yada, yada. That is the negative binomial probability distribution. All right. So let's take a look. Let's try to get the intuition here on the negative binomial distribution probability mass function. So let's try to do another explanation of where each of these terms comes from in the probability distribution. All right. So in the negative binomial experiment, there's one really key thing that we can focus on that helps us dissect this. And that is the trials are repeated until k successes occur. All right. So they repeat until you get k successes. So let's say you're doing something like rolling a die and you want to roll the die until you get your third 6. All right. Well, as soon as you get the third 6, you stop rolling the die because you've met your objective. So that means in a negative binomial experiment, the last trial always is a success. Note that the last, or in this, well, if it's takes x tries, that would be the xth trial, is always a success. Is always a success, right? According to the negative binomial experiment. All right, is always a success. So that means essentially what your event looks like is, depending on how many successes you need, but you're going to have some number of things happening before it, maybe a mixture of failures and successes, right? So question marks, some question marks there. And the last one is a success. The last one is always a success, all right? So what about these unknown trials before the last success? Well, if it took you x tries to get the desired number of successes, that would mean that there are x minus 1 trials before that. And in those x minus 1 trials, there has to have been k minus 1 successes. K minus 1 successes, right? Because you got this is your kth success right here. That's the kth success. The kth success is the last one. So there's k minus 1 successes somehow interdispersed into the previous x minus 1 trials. And so if we have x minus 1 trials, k minus 1 of them are successes, then we would have the difference of those numbers would be failures. There would be x minus 1 minus k minus 1 failures, right? What is x minus 1 minus k minus 1? Well, that is just x. Let's see here. We're going to have minus k, and then negative 1 minus the negative 1. That's negative 1 plus 1. That's just x minus k. So you've got x minus 1 trials, k minus 1 successes, and x minus k failures, right? So here we go. We can start to see where these terms come from. Let's take a specific order of these. For a specific order of k successes and x minus k failures. Remember, this is still like a binomial experiment. All the trials are independent. So we can say by independence, we can calculate the probability. The probability of a specific ordering of these successes and failures would be p times k minus 1, probability p of each of those k minus 1 successes. There is q, or 1 minus p, failures. No, sorry. Probability of q, how many failures are there? There's x minus k failures. And the last success, the kth success, or the kth trial is a success. So times 1 last p. And so naturally we can combine our like terms. This is just p to the k power q to the x minus k. And that gets us the last two terms in our probability distribution. And I think we can see where we're going here. That combination term then, this is for a specific order. So how many ways are there to have this ordering? Well, we need to choose the k minus 1 successes in the first x minus 1 trials, right? The number of ways of choosing k minus 1 successes in x minus 1 trials, then is k minus 1 choose x minus 1. K minus 1 choose x minus 1. Hence, k minus x minus 1 choose... what do I have? These are backwards here. Careful. What am I choosing? Choosing k minus 1 successes out of x minus 1 trials. So x minus 1 choose k minus 1 there. Careful. And there we go. And now we're good to go. Naturally, if you're getting k successes, it's going to take at least k trials to get k successes, because you can only get one success at most per trial. So that's our intuition on that. All right. Let's leave it at that for now. In the next video, then, we'll go ahead and take a look at a handful of examples of applying the negative binomial distribution.